Hello and welcome to another lockdown lecture Q&A session. We're here with John Slattery today, who works at the University of York studying ionic liquids. John, if you'd like to give a little introduction to yourself.
Thanks for the introduction. Yes, so I'm really interested in ionic liquids. Ionic liquids are very unusual fluids that have a range of unusual properties. They're essentially salts, like the salts that we come across often in our daily lives, but in a liquid state. But they are liquid at very low temperatures, so we can access the unusual properties of liquid salts at and around room temperature.
Could you give some examples of how your research is used in the outside world?
The current focus of what we're interested in is trying to understand ionic liquids much better. And the particular focus of our own research is on understanding how we can improve their properties for use in catalytic applications. So catalysis is really important in a range of industrial processes. So everything from the production of petroleum-derived small molecules through to the production of high-value compounds like pharmaceutical APIs or agrochemicals. So if we can provide better ways of doing catalysis, then we can access better ways of accessing these kind of small molecules.
What problems have you encountered so far in your research?
Yeah, so this is an interesting question. I guess research is all about problems, actually. So when we teach undergraduates in the undergraduate labs, we set up experiments in advance. And by and large, we know that these experiments should, in principle, work. And if everything is done correctly. When you're doing research, you don't know what the outcome of a particular experiment is going to be. And so often you're trying something with a hypothesis in mind and you have a bit of an idea of what you think might happen. And then what actually happens is often something completely different. So the problems that we encounter tend to be because we're working in areas that nobody's worked before. And so we don't really know what to expect. So one of the interesting things about ionic liquids is that they have very low vapor pressures. They are very involatile. If you have a traditional molecular liquid like benzene or ethanol or something like this, you can purify it often by distillation because it has some vapor pressure. And so if you want to purify your molecular liquid, you might just distill it a few times to make sure it's really, really super pure. If you have ionic liquids that don't have an effectively measurable vapor pressure, then you can't purify them by distillation. So you have to go through some different routes to be able to try and purify them. So this is one of the problems that we frequently encounter. We might make a new ionic liquid or a new combination of ions, but in order to study its properties carefully, we need to control its purity. We can't often purify these things at the end of the synthesis. What we have to do is to devise a very clean way of making them in the first place that doesn't involve introducing any impurities.
What would be your favorite aspect of your research?
This is a quite hard question, actually. I think there's lots of different things that I enjoy about it. When you do a reaction or when you make a measurement that nobody's ever made before, seeing the results coming back and that you're the first person in the world perhaps to ever have observed something, it is really fantastic. And so ever since I was a graduate student and started doing research work, it's been a real pleasure to be able to see those new results coming back and thinking, yes, I'm discovering something nobody's ever seen before. The other highlight for me is working with lots of people around the world with different backgrounds, different interests, different expertise, and collaborating to be able to bring to bear a range of different techniques, a range of different expertise to be able to try and understand the systems that we're working with. If you work alone, you can do quite a lot, but your expertise is always limited. And by working with lots of other people with different expertise, you can really solve a lot more significant problems. But also it's really cool just to work with people from around the world and get to know different people.
What reason would you give a student to pick chemistry at York?
I think chemistry is really exciting because it's quite a varied subject. So chemistry kind of sits at the interface between physics and biology, chemistry, maths, and it involves all of those different kind of aspects. So as a chemistry student, you get a chance to be exposed to lots and lots of different areas and to develop a really quite broad set of skills. During your degrees, you also get a chance to then focus down on the areas that you're interested in. So if you're more on the physical side of things, then a chemistry degree will give you a chance to kind of focus more down on the physical kind of chemistry. If you're more interested in biological aspects, then doing a chemistry degree allows you to focus a bit more there. But I think for me, the breadth of the subject is really useful and really gives a great opportunity to develop those skills.
Who is your favorite chemist and why?
I was thinking about this question. I think the person who kind of springs to mind, at least because we have a bit of a link to her, is Dorothy Crowfoot Hodgkin. So my research group works in a building at York, which is named after her. And personally, I find her to be quite an inspirational figure for a range of reasons, not least because she worked on X-ray crystallography, so the study of molecules using X-rays at a time when it was really, really difficult to do this. I have a huge amount of respect for scientists like Hodgkin, who were working in this area at the time, who were able to derive the molecular structures of complex molecules like penicillin without using all of the powerful hardware and software and methodologies that we have access to now. Really impressive.
So a more serious question, how has the current COVID situation affected your work?
Like everybody else, we had a lockdown period where the lab was closed, and that meant that any experimental work that was going on in the lab had to cease. Fortunately, my group also do some computational work alongside our experiments. What we find is that by doing computational work, we can get complementary information about the systems that we're studying that help us to understand the results of some of the experiments that we're doing. And so when the labs were shut down, we actually moved a lot of the projects that we were doing into a phase where we were looking at doing some computational work. So I would say it changed the way that some of the students' projects were working, but they were able to still carry on and do some things. For some of the students, it's had a bigger impact than others, where their project was much more experimental. They've had to change direction a little bit. And now that we're back with the labs open, they have to focus hard on trying to catch up on some of the work that they weren't able to do while the labs were closed. And we just have to be a bit adaptable, like many people have been around the country and around the world, and find ways of working in unusual ways. I think one of the potential benefits of this is that we are perhaps thinking a bit more outside the box in terms of the way that we're working. So if you're looking for some of the positive aspects, then being a bit more flexible and thinking outside the box in terms of how we're working has been one of the less negative aspects of what COVID has brought.
So what moment would you say you are proudest of in your scientific career?
There's lots of moments I think I've been really pleased with. I think probably the proudest moment was the first time that we had a paper published that was based entirely on my work. So as a scientist, you have access to all of the published work from scientists that have gone before you for hundreds of years. And that published work forms the foundation of everything that everybody does. So it forms the foundation of the undergraduate talk program, but it also forms the foundation of all of our kind of research. So when your first paper is published based on your work, and your work becomes part of this history, this wealth of knowledge in science, it's a really proud moment. You realize that this is a contribution that's always going to be there. Once it's published, it's there, it's recorded. It's going to be accessible to people presumably forever in the future. And hopefully that's something that people will be able to look back on and use in their day-to-day life in science, but hopefully in the wider world as we move forward into the future. So that was a really proud moment.
So final question, what other research is going on in the chemistry department that you'd like to contribute to if you could?
So one of the really cool things about York actually is that it's already really collaborative. So you will see a lot of collaborations between different academic research groups around the department. And my group actually already collaborate with quite a few different people in different parts of the department through existing collaborations. So I guess we already do quite a lot of this, but we're always looking at what everybody else is doing, and my colleagues are doing some fantastic work. So areas such as green and sustainable chemistry are areas where some of the work that we're doing will have some contributions, and there's always the potential for new collaborations there. And things like catalysis, which is going on in a range of different research groups, it's obviously something that we can have a contribution to as well. And so we have some collaborations going on in this area already, but there's always scope for some new ones. It'll depend what people are looking for and what we can potentially offer to help people solve their own problems.
Thank you very much.
Thank you.
Thank you.
Okay, see you guys later.
See you.
Bye.